Question 6 says a force I cap plus 4j cap Newton acts on a block as shown in the figure. The force of friction acting on the block is something that you have to calculate. Dear students, herein the maximum value of frictional force, let us first find out that, will be equal to mu into n. Now, the force has an ith component 1 and the jth component as 4. There will be a downward gravitational pull that will be 5g, that is 50 Newton. There will be an upward normal as well. Now, since the block is in vertical equilibrium, we can write down that n plus 4 will be equal to 50, or n will be equal to 46 Newton. So the maximum value of frictional force, therefore, dear student, will be equal to mu, that is 0.3 into 46, and this will be equal to 13.8 Newton. Now we can clearly see that the maximum value of frictional force is much greater than the pulling force, that is 1 Newton, and hence the frictional force will be equal to 1 Newton opposite to the I direction. And hence for this question the correct answer is option number 1. Moving on to the question number 7. In this question, a body of mass m moves with a velocity v on a surface whose frictional coefficient is given. So frictional coefficient mu is given as 0.4. The body covers a distance s is equal to 8 meter before stopping. Then the value of v is something that you have to calculate. The students, here the retardation will be equal to mu g, that will be 4 meter per second square. Now from the equation of motion, that is v square is equal to u square plus 2as, we can put v to be equal to 0. So this will be u, that is given to be equal to v here only. So v square minus 2 into 4 into s, that is 8. So v square will turn out to be equal to 8 into 8, or v will be equal to 8 meter per second. And hence for this question the correct answer is option number 1. Moving on to the question number 8. In this question, a small block of mass m slides down on a ramp at inclination angle theta with the horizontal. The coefficient of friction between block and ramp is mu is equal to mu naught x, where mu naught is a constant and x is the distance through which the block slides. The distance covered by the block before stopping is we have to calculate. Now dear student, the net acceleration, let it be a, so we can write down that mg sine theta, that is downward force, minus friction F is equal to ma. Now this will be mg sine theta minus mu into normal, that will be mg cos theta is equal to ma, or mg sine theta minus mu naught x mg cos theta is equal to ma. Here m will get cancelled out and we can write down a to be equal to v dv by dx, and this will be equal to g sine theta minus mu naught x cos theta. What we can do is we can bring dx on the right hand side, so dx comes here, and consecutively we can integrate. Now the integration limits will be from 0 to x and the velocity will be 0 to 0 as it stops and starts from rest as well. On the right hand side we get a value of g sine theta x minus mu naught cos theta x square by 2, and this will be equal to 0. On solving we get a value of x to be equal to 2 tan theta by mu naught, meaning that for this question the correct answer is option number 1. Now moving on to the question number 9. In this question, a system shown in the figure, all surfaces are smooth. Rod is moved by an external agent with an acceleration of 9 meter per second square, vertically downwards. The force exerted on the rod by the wedge will be. Now dear student, as per the constraint, let the acceleration of wedge be AW and let the acceleration of rod be AR. We can write down that AR by AW will be equal to tan 37, which means that the acceleration of wedge will be equal to AR by tan 37. AR is given to be 9 and tan 37, dear student, will be equal to 3 by 4, giving a value of acceleration of wedge to be equal to 12 meter per second square. Now dear student, there will be a normal force on the wedge which will be in this direction, and in the horizontal direction this n will have a component n sine 37. This will be the force responsible for the acceleration of the wedge. So n sine 37 can be written to be equal to the mass of wedge multiplied by acceleration of wedge. Consecutively, n into 3 by 4 can be written to be equal to mass of wedge, and the mass of wedge is 10 and acceleration is 12. From this, n turns out to be equal to 200 Newton. If we see the options, we can clearly see that the option number 3 matches our answer, and therefore option 3 is the correct option. Now moving on to the question number 10. In question 10, for the arrangement shown in the figure, the coefficient of friction between the blocks is mu. If the blocks are identical, then the acceleration of each block has to be calculated. Dear student, let this be the lower block. Let us write down L here, and let this be the upper block. Let us write down U here. The masses are M for each. It is pulled by a force F. There will be a tension here as well, T, and a frictional force small f. On the upper block, there will be a friction force in the right direction and the tension in the left direction. Now, for the upward block, we can write down that T minus F is equal to ma, and for the lower block we can write down that F minus small f minus T is equal to ma, as the accelerations should be same. If we add these two equations, we get F minus 2 small f is equal to ma, or acceleration to be equal to F by 2m minus mu g, as we put F to be equal to mu mg. And therefore, for this question, the correct answer should be option number 4. Now let us move to the question number 11.